energy engineer at CSU. I've been at the university 21 years next month. For those of you that know me in previous lives from some of the work I've done here in town, before I came to CSU, I didn't hold a job longer than 3 years. So obviously CSU's done a pretty good job of keeping me amused over the years. I'm here to talk about our geoexchange system that's coming to CSU, and we're all really excited about this. Frankly, we've been working on it since 2012, trying to make it happen. So for those of you that have been working on a project forever and it's not going to happen, it's not going to happen, not going to happen, it finally does. So sometimes there is a Santa Claus, you know. So. But first of all, I was going through some pictures, getting ready for another presentation, and ran across this one. So there are some people in this room that know exactly where this is from, and they aren't allowed to answer. How long ago was that, and where was that? Anybody?
Your backyard.
No, I wish. Yeah, no. That is Platte River. Yes, it is. That was part of the 10 kilowatt system that we put in drumroll, 1987. If you don't remember, does anybody remember who made these things? Martin Marietta. Martin Marietta made those Fresnel lenses. PV was so expensive that they had these little solar things down at the bottom of those Fresnel lenses. The problem is, tracking technology was not good enough at the time, and this gearbox right here blew out twice in the wind. We took that whole system down probably less than 2 years after we put it up. It was a pretty giant sail, and in the winds we had, it just, yeah. So anyway, I thought that was a fun, that's from, good Lord, what is that, 33 years ago now?
But have you seen their new array going up there?
Yeah, yeah. They actually gave me one of those. This was my master's thesis project, by the way. They gave me one of those panels, so I have a 30-year-old solar panel. I haven't plugged it into anything. So, and then the other thing, we're going to talk about GeoX eventually, but first I have to talk about some other stuff. So, CSU, we're really excited. We just got recognized. In higher ed, there's this group called the Association for the Advancement of Sustainability in Higher Ed. It's called ASHE. They have a sustainability rating system called STARS, Sustainability Tracking Assessment and Rating System. And we were the first university in the world to ever get platinum in that rating system in 2015. We held that position as the only university to hold that status for 2 years. Nobody caught up to us. And then finally, Stanford sends out a press release and says, Stanford joins Colorado State as the only 2 platinum institutions. So that was in 2017. You have to update your stars every couple of years. So we repeated and we just three-peated. It says 2019 because you submit it and then you go through this whole review process. So we just found out we got it a few weeks ago, but we actually submitted it in December. So the date on it is the date you submitted it. So anyway, we're pretty excited. Only university to ever three-peat platinum. So now, so what does that mean? It's a self-reporting system with 1,000 data points. Okay, that just tells you where it's at. 1,000 plus, actually. Those are the categories. That's actually comparing us to ourselves. As it gets darker to the right, those are the years. So first couple times we submitted, we were gold, and then we've had 3 platinums. So you can see operations, which is my world. I always joke when I saw this, I was like, most improved. Okay, right? And my friends who work in academics and research, it's like, well, it's hard to improve from 100%. Hello. So, yes, and I will just state that the bar is very high in stars. For example, to get all the points in new buildings category, you have to build all your new buildings to LEED Platinum. That's a tough gig, okay? You get points for LEED Gold and you get points for LEED Silver, but they're lesser points and you can't get full points. So it's that kind of, the bar's just set really high in operation. And we're pretty excited to be over the 60% mark. So anyway, that's where we're at. So you can see our overall score. And for the record, 85 is platinum. So we're over the line, but not by a lot. So let's talk about why are we doing all this sustainability stuff? Well, it's been part of the core tenet of Colorado State University for a long time. I tell people I came to Colorado State University in 1978. Back then, we could get a mechanical engineering degree with an emphasis in solar energy, and I have one of those. But the only two universities at that time that were teaching solar engineering was us in Madison, Wisconsin. Okay? So we've been doing this for a long time. There's some of my fellow Solar Village alumni. It's kind of sad because the Solar Village has been torn down. Those buildings were not built to last. Let's just put it that way. So we've been doing this for a long time, but just in the last decade or so, we've made a lot of pretty significant commitments. The first one being the AccuPact commitment, which says we're going to take our university to carbon neutrality. Okay? We had 2 years to write our first climate action plan to say how we were going to do that. We did that in 2010. We've updated it. We're actually in the midst of an update right now. But we lay out the strategies as how we're going to get to carbon neutrality by 2050. Now, we can have a very long conversation about whether 2050 is good enough. And we are having those conversations right now in our 2020 update. Because with all the things that Mother Nature is telling us, 2050 may not be good enough. So we're working on that. And then, this is a big one. In 2017, we signed the pledge, well, we didn't, he did, Tony Frank was our president at the time, that says we're going to commit to 100% renewable electricity, not energy, electricity, by 2030. Okay? Now, I will say, I don't know if my friends from the utility are in here, we got called on the carpet for that. I will be really blunt. They were just like, what are you doing? Do you know what you're doing? Well, no, not really, but we'll figure it out. We got 10 years, 12 years, whatever. But ironically, a year later, the city in Platte River caught up with us and said, you know, that's probably a pretty good idea. So, anyway, we'll talk about that a little more. So, when we talk about carbon neutrality, we have to say, well, what's the problem? What is it we're trying to get rid of? That. Okay? Actually, when I do this in front of students, I usually put one up there without the labels and make them guess. Electricity is not the one they guess. There's 8 categories up there. I was in front of some kids the other day. Took them 6 guesses to get to electricity. Like, there's only 2 left, you know? So, you look at that and it's like, it's an energy problem, right? Transportation, which is really what commuting and airline travel is the other kind of big piece of the pie. But the other 4 you could call de minimis. Agriculture. We are a research ag university. This is, by the way, all of our campuses all across the state. We have 3,000 cows and hundreds of horses and sheep and fertilizer and all that. And it's 4% of our footprint. Okay? Putting human beings in building and conditioning those buildings and lighting those buildings and putting computers in those buildings uses a lot more energy than raising a cow. Okay? So that's why our footprint looks like that. So that's the problem we got to fix. Okay, I got to make that pie go to 0. That's my job.
So is that commuting includes students?
That is students and faculty, yes. Students, faculty, and staff. That's everybody. Yep. And I will tell you, the students are good, faculty and staff are not. Okay? Basically, roughly, round numbers, 2 out of 3 students come to campus by some mode other than single occupancy vehicles. Staff, it's the exact opposite. 2/3 of us come to
Does
campus.
staff get a free parking pass?
Nobody gets a free parking pass. Who are you kidding? we get ticketed on campus in facilities vehicles if we're not careful. Yeah, no. Parking management doesn't give anybody a buy. No. Nice try, though. So I talked about the 100% carbon-free commitment. We've made that commitment. The cities and Platte River followed. Excel, and now even Tri-State. I swear, when I heard that announcement, I'm like, snowballs in hell. So I used to work in the utility biz before I came to the university, and Tri-State has never been the pantheon of, sort of cutting edge. So, we're back to my grit, my pie. My problem is half electricity. Well, voila, the electric utilities are going to solve that problem for me. So, what is it we're going to do? Okay, now imagine that pie is half as big as it was because we got rid of the electricity. What is the problem when the electricity is not a problem anymore? Okay, in 2030, we've got a green grid. That problem solved. This is my new problem. So now all of a sudden my 50% problem is natural gas. Well, that's way harder. And I will tell you some news I just got this week. What do you think the university just locked in natural gas at for 2022 and 2023? Just barely over $2. That's what we were paying for natural gas when I started at the university in 1999. How do I compete against that? Anyway, I'm ranting. Okay. That I tell her, it's like when she showed it to me, it's like, because we were $3 just a couple years ago, and we use enough natural gas that if we save $1 per decatherm, that's $1 million to the university. So it's a big deal. Like, it's a really cool thing, but I'm like, can I have that $1 million to do some other cool stuff with? But probably not.
Is that due to fracking, by any chance?
I'm not an expert on the natural gas field. I will not speculate as to why natural gas is tanking in price. I have jaded conspiracy theories, like maybe they believe we're going to actually elect a person who might impose a carbon tax, so they're trying to burn it all up quickly. I don't know. I'm a great conspiracy theorist person, you know. So we're going to talk about this project, and I thought, actually, my great friend and coworker Stacy was the one that suggested this. Let's lay it out. Let's say, you know, because not everybody hangs out on campus. I can talk about all these places, and you don't necessarily know where they are. Upper right-hand corner, the oval that we all know and love. The district heating plant, which was originally coal, by the way. That's why it's by the railroad tracks. There's been natural gas since the 60s, but 3 big, huge natural gas boilers create steam, and we pipe that steam all around campus, and that's how we heat and provide hot water to almost all of our campus. Okay? Now, that system is, there are parts of that system that are 100 years old. The tunnels and some of the other stuff. The piping and the boilers are newer than that. But the problem is, over here on the oval, it's not like we get to do building expansions over there. It's pretty cozy over there and all pretty sacred. So as we started to get to capacity on our district heating plant, we had to say, where do we get that capacity back from? You know, we can't install giant boilers over there because the building's just only so big. And we also looked at it and said, well, we can move the district heating plant, put it somewhere else. Well, the combination of building a new building and running steam pipes to said new building, that's a multi-million-dollar project and starts looking pretty ugly. So many years ago, the decision was made that this is Meridian right here, that west of Meridian, that the goal was to take everything west of Meridian off the steam plant. And there's a lot of reasons for that. For those of you who know anything about steam systems, they make a lot of sense when you have a dense, sort of urban-like core, which we do pretty much in this part of campus. Over here, I always joke, what does it cost me to deliver a gallon of hot water in Ingersoll in the dead of summer? If it's coming from a mile away, right? It's not a very cost-effective thing. So these buildings have gradually been coming off of steam, most of them going on natural gas, and we'll have a conversation about that another day. But when we started looking at all this, most of these are housing buildings. And housing and dining, for those of you who don't know how we work at the university, is like a whole different group. They have their own facilities people, they do their own thing. But our building over here that we had to worry about was the whole Moby Complex, okay? 300,000 square feet nearly. How do we take care of Moby in a sensible way? Back in 2012, we said, we have this giant field over here. Can we do a ground source heat pump? And we actually paid a group to do a study. They came back and said, well, Moby doesn't have any infrastructure now besides steam heat exchangers, right? And a couple of air-cooled chillers sitting over here. And so they basically said to add cooling to the whole building and to replace that steam heat, we'd have to add a little, we called it a wart, a little building, to Moby to house a boiler and a chiller, sort of a traditional system. So the cost of that additional building meant that something like a ground source, which is a high first cost, started to look like it made more sense. Okay? So that was one of the things that got us to the point where we could say, okay, all this is going to come off steam and Moby's going to go on ground source. Now, I make that sound really easy. We started in 2012 and we got approval in 2018 or 19 sometime, and then we had to go through the whole process of getting it going. So The other thing I'm going to talk about tonight, Meridian Village, for those of you that have ever been on campus. Who was a student and actually lived in Aylesworth? Anybody? It was a dorm at one time, and then it became an office building, and then we all were very joyful when it came down because it was a terrible building. And it is an empty field right now, and they're rebuilding it, and that's going to be a giant residence hall complex. So we're going to talk about that, but that's going to go on ground source as well. So why did we do this? Okay. Moby is 1960-something vintage, 50-year-old. Some of the equipment in that building is original, actually way more than I care to admit. That's how we do things at the university. Talk about the steam system. Ground source is lower emissions, higher efficiencies. It's just a better way to go, and we were able to prove that it was the lowest life cycle cost. And ironically, those sports fields that we're going to tear up when we make a bore field were in terrible shape. They had been asking for years to restore those, and restoring sports turf is a couple bucks a square foot. Okay, it's a pretty pricey thing. So we were able to absorb that in the project, in that when we're done with the bore field, we'll restore it to sports turf quality, and those fields will be better than when we started. So it was kind of a combination of things coming together. We call it GeoX, that's kind of our cute little nickname. It's technically a geoexchange system. People oftentimes use the word geothermal. And I always tell people, unless you live next to Yellowstone or someplace like it and you have 180-degree water right below the ground, it's not technically really a geothermal system. Geoexchange is really more accurate. Ground source heat pump is always, but that sounds way too nerdy, so we just go with GeoX. And then we'll talk more about how we do it. Construction is underway right now inside Moby. We'll be outside after graduation, but the really cool thing, Meridian Village is 6 months behind it, and so as soon as we're done with the bore field in Moby, they'll move over and start drilling for Meridian Village. So, really quick, I threw this slide in here for the folks that don't live in Fort Collins or haven't ever been to a basketball game. The Moby Complex is nearly 300,000 square feet. It's got everything from a basketball arena at one end. I joke, those of you that don't know, I'm a huge volleyball fan. I have front row seats. And if her arm wasn't there, I would be in this picture. So, but at one end, we've got this 8,000-seat basketball arena. At the other end, we've got a swimming pool. Swimming pools, and if you don't know, NCAA pool is, I don't know, it's like 80 degrees, plus or minus like 1 degree. Like, they really care about what temperature their pool is. So we spend a lot of energy heating the swimming pool. And then there's all kinds of stuff in between, okay? Human performance labs, just all kinds of things. So it's a really complex building, but actually a really great building for ground source and heat pumps, because there's a significant amount of time that we're just moving heat around within the building. We won't even need to go to the field except on hotter or colder days. On moderate days, we'll just be moving heat around. Fun facts, it was funny, Stacy and I were talking, I was like, how nerdy should I go with this crowd? And he goes, oh, uber nerdy, okay? We were talking about the city's heat pump system that they did out of the pond next to their Wood Street facility, and they did a lot of smaller. We're actually doing 15 pretty good size heat pumps. They will be more centrally located. We're actually piping around the heating and cooling loops more so than the district, than the loops that go to the bore field, okay? There's efficiencies, all that stuff. This is a really interesting thing. The people that do a lot of work in this, the train, trace, and all those tools that people use to estimate building loads are not well suited to model moving loads in the building. So they can model it, and they said, that's the worst it will do, because any sharing within the building is not accounted for, okay? And then these efficiencies obviously don't include pumping power. Oh, somebody asked me how many boreholes? 342. We were going to do 500, the original guess was 500 wells, 400 feet deep, and then they found out they didn't have enough physical space for that, so it became 400 wells, 550 feet deep. And then when they refined their design after a test bore for thermal conductivity, they refined it down to 342. It will be 70 miles of pipe. These are closed loop piping, so it's just going to send water down a U-shaped pipe and back up again. It's just a big heat exchanger. And some of our early press said it's the largest one in Colorado. I think we have more boreholes, but IKEA is technically a bigger building, so we have to be a little careful about saying who's the biggest. Not like universities are competitive or anything. So here's our graphic that basically says we're going out here in the middle of this field, which, by the way, the field is awesome because it's a floodway. Right? Those of you who were in 1997, that field was 4 feet underwater. We can never put a building there. So we can fill it with borefields without worrying about anybody wanting to use it for a building site. So it's just a giant heat exchanger. That's all we got. Giant heat exchanger, 70 miles of pipe in the ground. Below, a few feet below the surface, the ground's 50 degrees all the time. So we'll get 50-degree water back, and we'll use that with our heat pumps to heat and cool the building.
Carol, what are the gray tank-looking things?
They're vaults. They're not really tanks.
Repeat the question.
Oh, I'm sorry. The question was, what are the gray things? They have header vaults. I think that's probably the best thing to call them. Yeah, and they're huge. They're ginormous. Because this is a lot of water. I can't remember what size pipe that was. I want to say it's a 12 or 16. It's big. It's really big.
What's the spacing between the boreholes?
Oh, God. Okay, yeah, I knew there was going to be questions. I want to say 20 feet, but it might be 25. I know we had conversations about that because spacing between boreholes is a big deal because thermally they can start to interfere with each other, right? Because in the summertime, you're dumping heat into the ground. So the ground is gradually warming up, although my friends at Poudre School District tell me that they've monitored their well field, and they said it raises a few degrees, but about the time it starts getting a little bit warm, it's fall and they want, no, it's the other way around. And they want to pull heat out of the ground, and so it reverses. So it does a little bit of that. But yeah, that was part of why we went deeper, so we can make sure we kept them far enough apart.
Where's the water table?
That's a great question. We actually hit water at 12 feet, and where's the other? But these, yeah, well, actually it's not, because you have this U-shaped pipe, and I want to say it's 1 inch diameter. It might be 1.5 inches. I wish I knew these questions better. I should have done my homework. But it's a big, 550-foot U-shaped pipe, and they drill a well, they put the pipe in there, and they immediately fill it with conductive grout. So the well is sealed as soon as they drill it. So there's no contamination between aquifers or anything like that. It's a closed well when they're done.
Carol,
Yes?
how would you do maintenance on that?
You don't, okay? That's a great question. You basically have them set up where you can header, if you have a well, if you have one that fails, okay, it's HDPE pipe, you guys all know what that is. And then there's a special U-shaped fitting that they fuse on the bottom. They pneumatically and hydraulically test the pipe before they put it in the hole, and then they header them together and test them again. You test it, there's this whole process of making sure that you don't have leaky
It's got a
wells.
lifetime to it though, at some point, doesn't it? Nothing
Good
lasts
question,
forever,
good question.
so. You're gonna
They
figure that out.
they claim 40 years, but I'm like, show me the 40-year-old one. It's
Right.
Yeah.
Metal or plastic?
it's HDPE, high density
Plastic,
polyethylene.
okay.
Yeah.
No corrosion.
No. And so this is my, I give these presentations around different places. You guys know what a heat pump is. You guys know the refrigeration cycle. But I always tell people, you got a refrigerator. It makes cold on the inside, but on the back or the bottom, wherever the coils is, it makes hot, right? So that's what a heat pump is. You can take heating or cooling off that device depending on what you're trying to do. But we're not the first people. My friends at Poudre School District did this a long time ago. Their facilities building on LaPorte Avenue was their first one. They've done a couple of them. And I think their new high school they're building across the interstate on Prospect is going to be ground source as well, because they've told me they're mad at me because we're tying up all the drilling rigs. So, and these are other people that have committed to it. Ball State University is kind of the poster child. They kind of had the same kind of thing we did. They had an aging coal-fired steam infrastructure, and air quality laws were going to shut down their coal, so they were either going to have to completely rebuild it with natural gas, or they said, wow, we could do ground source heat pump, but they had to do new piping over their entire campus. So it was very disruptive. Actually, Stanford has also recently done this. You know, imagine 2.5 years of tearing up every road on campus at Stanford, putting in new pipes. That's the kind of scale people do this in. So, and then Colorado Mesa, in our own little corner of the world, used to be called Mesa State over in Grand Junction. They're nearly all ground source. But for us, it's not just Moby. That's the only rendering I could find of Meridian Village. It's huge. You can count how many stories on those buildings. But it's going to go right adjacent to the stadium. So they figured massing-wise, they could get away with a 5 or 6 story building. So this new housing project that's going to go where Aylesworth was is set to be on ground source. And for those of you that know our campus, Newsom is the other one that's just west of that site. When this gets done, Newsom comes down and another version of this goes up, okay? CSU is growing.
How many people?
How many bodies in this one? There was, at one point it was 1,600 beds, but they didn't get as much money as they wanted. And I think it came back down to 12 or 1,100 beds, over 1,000 beds. So, this is the fun part. It will get ugly. I love this picture. It's like, okay, there's only 3 drilling rigs in this picture. We need 6 running full-time from May through August in order to get 342 wells drilled over the summer, okay? So there will be 6 drilling rigs, let's try that again. Drilling rigs working continuously, well, continuously as much as we can in Fort Collins. You can't start before 7 a.m., and I think you have to be done by 6 p.m. per noise ordinance.
Is that diesel or is that electric, those drills?
The drilling rigs? Diesel, I think. They're certainly not electric. We're not hooking them up to anything. So yeah, it'll be messy, dirty, dusty. It'll look like that. And loud. We actually have already bought sound monitoring equipment because we anticipate complaints. So we're measuring background noise from the, out in the middle of that field, there's pretty significant road noise from shields already. And hopefully, because it's summertime, the people that will be most impacted are the residence halls just south of it, okay? But fortunately, nobody's going to be in those. There may be a few conferences that might be a little problematic, but we're going to have signs on the fence telling them how cool it is. So hopefully that will. But I showed you in that first map slide that we have a set of fields that we're going to be drilling our 342 wells in. But then we're going to be done by August. But then these drilling rigs are going to move across the sidewalk and start drilling for Meridian Village. So it's going to go well into the fall. We're going to be drilling for about 6 months this year. Okay? So it's going to be, yeah, please tell your neighbor, be patient with us. And we joke, it's like, well, we could put up a sign that says, well, the state won't fund us, so we started fracking, you know? But you got to be careful with those things.
You can always say that you're not using as many drills as connection is.
There we go. And actually, it turns out you learn things on these projects. The rigs that are going to be out here are more like what you would use to drill a well in the mountains. They're smaller rigs than what they use for fracking. So they're not even the same trucks.
What was on the east side of the new business building? They were doing a whole lot of excavation and piping when they were putting that in. I thought that was ground source. Just
East
from the
side
volume.
of the new business building. I'm not sure where you're talking. We'll go back to the map in a minute and we'll go there. Let me just finish because I'm actually getting close to the end. Inside Moby, I told you we have very, very old equipment. What's really interesting is we had a building that was running on steam heat exchangers. So the hot water loop, the steam came into the building and immediately went to a heat exchanger, made 180-degree water, and we use that to heat the building and make hot water, okay? That's 1960, they designed it, it worked. Well, then we were going in with ground source, which many of you may know or may not know. You can't hit 180 degrees with ground source. You're lucky to hit 140. We're designing at 120. We think we can hit 130. Okay, so just to give you an idea. Well, it turns out there's a couple places in Moby that aren't that used, And we couldn't afford, okay, this is 1960s building, I'll say the word out loud, abatement is killing us. You guys know that word, can you say asbestos, okay? So we're in a phase right now, and so there was an area we were gonna have to abate to serve an area that was kind of underutilized. And it turns out we decided to test the system. So we ran the system down to 120. We took the same system and said, that's serving the building now, said, what happens when we run this thing at 120? And it turns out we got through a pretty bad cold spell and there was no calls. So there's a piece of the building that we're going to use existing coils that we're used to running on 180, and we're going to run 120-degree water through them, and they'll be fine. And that way we don't have to abate them and remove that equipment because of everything around it. You know, I always tell people, asbestos is fine as long as you don't touch it. And then it gets ugly. So back to our map. Okay, here's where we're going to be drilling. This is actually part of a slide that we've been showing around campus construction impacts this summer. And there's actually about 8 slides to this. I'm only showing you 3 of them. Because it's going to get ugly on campuses. For anybody that likes to go through campus or whatever around campus, avoid it. It's going to get really bad this summer. This is us. We're going to be drilling here starting mid-May. The day after, for those of you that care, PSD graduation, not just CSU graduation. We're going to wait a week later and then start drilling until all the graduates get out of Moby. And then we'll start drilling in here. There will be some work that has to be done to connect that. But just to be aware, we're rebuilding Hughes Way. So that's going to get closed, okay? We're rebuilding this to add bike lanes, two-way traffic, a bunch of stuff. Oh, by the way, the Laurie Student Center reconstruction of the north end is going on. So the whole north end of the Laurie Student Center, you know that stairwell between the engineering building and the student center where everybody walks up? That's closed all summer. So you can't get anywhere just to like, this has actually already happened. I live in this building. You can't get down our block anymore. They've closed this for this Shepherdson rebuild. And this is a fun one. This will start spring break. Amy Van Dyken Way is going to get closed for about 6 or 8 weeks as well. So getting around campus is going to be a little messy. And if you look at this and say, how the heck do I get to the library parking lot? We're going to build a little road right there aligned with where Meridian comes in off Prospect to get into this lot because this will be closed. And then it gets worse. Okay. I laughed. The first time I saw this presentation, I said, I give. I'm not coming to work anymore. But it's like there's no entrance that's not impacted. Although these are 1 or 2 day paving projects and they will not happen on the same day. But this could start this summer. This is actually more likely, from what we understand now, is probably going to be bumped to the fall, but this whole area over here is going to get rebuilt with bleachers and all kinds of cool stuff for soccer and softball. What else is going on? Lots of fun stuff. It's going to be a mess on campus this summer, it really is. By the time August, if you're looking at the time frame at the top, by the time the students come back, we're done with it. There's still fences here, because remember, by August, I'm done drilling here. My GeoX wells are all drilled, but now we get to go over here and drill for Meridian Village, okay? So Libby Coy Way in my neighborhood over there is closed through. That is not a mistake. It's closed for 1.5 years. So yeah. And then somebody asked me early Major Geothermal. I couldn't remember whose company it was. This is actually, we hired, we have a lot of really smart people in our group, but nobody had ever done a ground source heat pump. So we hired an outside expert, and a guy named Terry's been our consultant, helping us write the RFP and judge the RFPs and write the specs and all that. And then the rest of this is the design build team that's putting it together.
Are you chilling the units in Meridian Village? Are you using heat pumps in each of the units? Or?
You know, I have not seen the final design for Meridian. It's interesting. They thought they were going to get, what was it, 150 million, and they got 110. I can't remember the numbers exactly. They didn't get as much money as they asked for. And so they've been in redesign for a while, and I have not seen it. I think they're going to, rather than having centralized heat pumps, I think they're going to have, probably by floor, not by room for sure, not, but they'll have a lot more smaller units would be my guess. But I don't know that.
Can you give us a cost perspective on geothermal, on the payback period or
Great
tax credits
question.
and such?
No tax credits, we're a nonprofit, right?
Well, that there are ways around it.
What's that?
Repeat.
Oh, the question, cost impacts and tax credits, that kind of thing. We're a nonprofit, as are all state universities, and so tax credits don't mean anything to us, and I don't even know if there's tax credits associated with this.
Oh yeah, 30%.
For geothermal?
Oh yeah.
Okay, well, I don't get it, sorry. But I don't pay any taxes either, so maybe that's not a bad thing. The project is a $20+ million project, so not big, small. But I will tell you, the bore field and the part outside, it's a few $1,000,000. Most of the work is what goes on inside Moby, and again, we are replacing, this is a deferred maintenance plus geoexchange project, to be totally honest. So if what we sold it on, the study we did in like I said, we started studying this in 2012. The study I think is actually dated 2013, where we compared a traditional boiler chiller system. Again, remember I had to build a house for that, I had to build a building for that, versus a geoexchange. And this was cheaper, but because I was building a structure, it made that one more expensive. And this one saved money in utility bills over time, so the life cycle cost said that this was the cheapest one. And the payback between the two was about 8 years. If you just look at, if you sort of take the deferred maintenance that we would have to do anyway off the table, and that was actually some of the funding, is state funds for deferred maintenance is part of the funding for the whole $20 million project. The rest of it, our VP for university operations finally bonded it. It went out for bond, and it's just like a new building. They're paying for it. So we're really excited about it. It's been a long time coming, and I just need everybody in my camp, when they're calling me up and beating me up all summer because I have 6 drilling rigs running simultaneously. You guys all need to go to all your friends and say, don't worry about it, it's a cool thing. It's really gonna make the town better. So, anyway, questions?
What's the relative ratio of heating load versus cooling load?
This is a heating-dominated building, pretty substantially heating-dominated building, and it's all about peak loads, and this drives me crazy. It's like, how can we build buildings better? But, okay, Moby Arena, full of basketball fans on a -10-degree night. Or actually, we'll pick an ASHRAE design date. What is that, about 0? And you got to ventilate for 8,000 people, and your air coming in is at 0. It's a huge heat load. Yeah.
I don't know if you do cost per ton CO2 mitigation. When you did the economics, did anybody run it with $1 per ton of carbon?
We did not use carbon in our economics. We basically have said that's a collateral benefit, is the reduced carbon. Yeah. And honestly, the reduced carbon doesn't come till the grid gets greener, right? We're working on that.
Well, the 2 final designs were what, primarily natural gas?
It was a traditional natural gas boiler and air-cooled chiller because we had no room to put a cooling tower there. And so the efficiency gains were the heat pump versus those technologies, yeah.
The carbon, you could do the math on the carbon.
Absolutely, yeah, yeah. And actually, what was interesting, that feasibility study we did in 2013 said, ironically, because of the efficiency improvements, the electric load only goes up a very tiny amount and the natural gas load goes away. That's essentially what happened, is because we were cooling with terrible air-cooled chillers. Okay, how many of you have lived in Fort Collins for more than 15 years? Okay, do you remember when Moby Arena was not air-conditioned? It's not that long ago, right? I have been to volleyball games in September in Moby Arena that were about 90 degrees because the air conditioning was added in the early 2000s. Okay, and they were just some skid-mounted air-cooled chillers. Oh, that's the other benefit of this project. This will get really fun this summer. Everybody's going to hate me. No air conditioning. The day after graduation, no air conditioning in Moby till about October. The whole complex. Yeah. So the reason is because where those air-cooled chillers sit outside Moby is where they have to go into the equipment room where all the heat pumps are going to reside. They need to be out of the way because we have to cut a hole in the wall and start moving equipment in and equipment out. Yeah. Question?
What percentage of gas will GeoX Field 1 and 2 displace?
Well, you got to remember, GeoX 2 is a load that doesn't exist yet. I mean, that building, it's a new building. So honestly, I can do once we have it and we know the loads, I can tell you what it would have been on natural gas, but right now I'm speculating. Yeah, with just Moby, how many decatherms of gas does Moby use in a year? I don't have that number in my head, but yeah, I cannot answer that question. But in terms of percentage of the whole campus, what's really interesting, let's go back to my map a minute. I'm going to make you guys dizzy. Well, here, look. This is a map, this works. Okay, remember my steam plant's way over here. And the line losses in this mile plus of steam lines I've got over here on this side of campus. Once Moby comes off, and let's see, they're working on Durrell and a couple more. Rec Center's already off of steam. Very shortly after we finish Moby, we will no longer need the steam system on this side of campus. So not only will I save the natural gas usage of this building, but I will save all the losses in those steam lines from here to here.
What is the loss
huge.
from
It's significant. Well,
I mean, we talking 50% or?
oh, no. But 5% of a big number is a big number. Yeah. I don't have, God, I knew you guys were going to ask me questions. Damn.
Sort of a follow-on to that, are you sub-metering to the building on your steam lines, or is it just kind of goes out?
Steam metering is, question, you're the one who keeps nagging me to repeat question. Sub-metering on steam. For those of you, anybody who works with steam meters are expensive and they fail a lot. We struggle to have good steam data all the time. All of our buildings on campus, we have hundreds of electric meters, hundreds of water meters. Almost every building is sub-metered for those utilities. Steam, I think we have 50, and so there's a lot of buildings we have to estimate steam. Moby had a steam meter when going up into this, but we started looking at the data pretty hard going into this project, and we're pretty sure it's not accurate. And for those of you who don't know, steam meters, one of the traditional ways we meter it is a turbine meter, and they need maintenance and they get destroyed over time and they deteriorate pretty quickly, and it's very, very hard to meter steam. Expensive too, so yeah.
So you're coming out of the field with water or some sort of water solution, right?
Right.
To go to the heat pumps.
Right.
Now, is any of that being used to heat other water, or is it just going to be for heating and cooling air?
Oh, good question. That was one of the things that was pretty problematic. Remember I told you we can make 130-degree water? Okay, what's the code for domestic hot water? 140. Somebody's got it. It's 140. So we have to boost with natural gas on the domestic water side. Yes, great question. There was.
Yeah, how close is the balance between the heating and cooling loads annually on the system?
I'll tell you that once it's up. Remember, I just told you that we think our steam meter data was maybe not accurate. And we're doing a bunch of improvements in the building. So when we're done, let me answer. I'll come back in a year and tell you how we're doing. How's that?
I'll be
Okay.
here.
All right. Okay.
Are you concerned at all about the thermal creep of the field? With the warmer winters?
That's a great question, but remember it's a heating okay, worried about thermal creep in the field. It is not a balanced load, but it's close to a balanced load. So it will, technically we extract more heat out of the ground than we put into the ground, but exactly what you just said, the weather, the climate is moving generally to warmer, so it will tend that towards a better balance. There's the word I'm trying to come with. So in the winter, we're dumping heat in this field. No, the other way around. Summer, we're dumping heat in the field. Winter, we're extracting heat out of the field. And if the climate warms substantially, we'll be dumping more heat in the summer, and it will get closer to balance. Because like I said, right now they're telling me, I was actually really suspicious, but they're telling me it is actually a heating-dominated building. And one of the things is we heat a swimming pool 24/7, 365. So there's this huge heat load on one end of the building.
The whole system is cooling and heating by water, right?
Well, within the heat pump, there's refrigerant, but yes.
Yeah.
Okay.
How much water are you going to be used, or how much you will have to replenish? How much consumption of water?
It's not gonna, it's all closed loop. So once we fill the pipes, it's not much water. When we fill the pipes, it's a lot of water. I told you 70 miles of pipe. Quick, how many gallons of water in an inch and a half? Well, yeah, whatever. Okay, you guys have to do the math here, okay?
And you gotta keep the water clean too, right? I mean, there has to be some
It's
way of-
closed loop. I'm sure there's some treatment involved. Again, this is new technology to me. I have never run a ground source e-pump. We are going to learn a ton in the next year. And by the way, this will be operational by Christmas time. We do not have much time to come up the learning curve. So we're all just like, yeah.
I had a chance to talk to the environmental engineer of IKEA,
Okay.
and he told me that when they built their geothermal system, they realized they basically had to stand next to each drilling rig to make sure they weren't screwing them.
All right. Great question. That's why we hired this guy. That's his job. He is our QC guy. And he knows a lot about, he talks about things, okay, we talked about how close can you put the wells together for thermal interference, but also 550 feet with a spiral drill, they can divert. And he said they'll run into each other. They're just 1% or 2 and 20 feet ain't much, right? I'm like, oh, would I have thought of that? No, but he talks about, that they, again, there's a ton of testing on the pipe, because the last thing you want to do is install a well field and then say, oh, 10% of our wells are leaking and we have to, shut them off. And yeah, that's not how this works. They designed this for 342 wells, and he said, when we are done, we will have 342 working wells. So,
You still have to have a contingency for failure, yes?
presumably, and we also have engineers that tend to grossly over-design things, so I'm not really too worried about it.
Harold, is there different bonding because of that to ensure that?
Different. That's a great question. No, I don't think so. There was no concern. There was actually very little concern about risk because all the risk is in construction. Basically, if you have a well that fails during the construction phase, they re-drill it, right? When we're done and all's tested, they tell me we will have 342 working wells. So
you do bonding for your projects, right? You just
Adolfson Peterson had to put a pretty big bond on the table to make sure that they can perform. You bet they did.
Which kind of bonding are you talking about?
Performance bonding?
Completion bonds?
Performance bonds, yeah. Can you make this thing work? Yeah.
And if you can't, you pay, not the university pays.
Correct.
What status is Moby as far as efficient buildings?
Not. It was built in 1960. Okay.
Is there any of this retro work that you're doing to improve the shell of the thing?
We are not improving the shell. That's way too expensive in a building like Moby. And ironically, in a building like Moby, where ventilation's a huge issue, it's not necessarily as good a payoff as you think it is. But we're doing a lot of replacing pumps, replacing fans, VFDs, all that sort of pretty traditional efficiency work. Replacing coils, lots of coil replacement. Because remember, these coils were sized for 180-degree water, and oh my God, do you know how they made coils in 1960? Seen with the little round fins on them? It's like, really? Is there any efficiency in that? So we will gain a lot of efficiency just by bringing in 50-year newer equipment in a lot of places. Lighting in Moby is interesting. Since I've been at the university, we've redone it twice. We did it with induction fluorescence once, but despite what they told us at the time, you cannot turn off induction fluorescence and turn them back on reliably. And what they want to do, how many of you have been to a basketball game at Moby? They like to do the special introduction where they turn off all the lights and put people under spotlights, right? But then the lights all have to come back on again. And that wouldn't happen with the induction fluorescence, even though they were a lot more efficient than the metal halides that we had when I got there. So we ended up replacing them. If you look up in Moby right now, they're hideous. T5s. T5 HOs in these fixtures. I think there's 8 to a fixture. Yeah, just look up next time you're in Moby. They are the ugliest lights. And my husband keeps reminding me, Nobody notices them but you, Carol. But sorry. But you can turn them off, do your little spotlight thing that they do during the introduction of the players, and then turn them back on and not worry about half of them not coming back on. Which,
shut their eyes.
They're not LEDs, those?
not yet, because when we put in the induction fluorescence, there was not an LED that would punch down 40 feet and give us a 100-foot candle. It's 100, on television night, it has to be 110-foot candles on the floor. And you couldn't do that with LEDs 6 or 8 years ago when we did the last round. We could probably do it now. There's a lot of people doing LED sports, indoor sports lighting. But at that time, it was too much.
Over here.
Oh, sorry.
You've been pumping this steam throughout the campus for a long time.
Correct.
In the ground.
Correct. It's direct. Some of it's direct buried. Some of it's in tunnels. Some of it's in trenches.
You've been heating the ground all this time, and you're going to cut back on that steam. Do you think that's going to have any effect on when you do your wells, on how much heat there is in that ground?
No, because our steam lines are insulated. Some places better than others. And back to my map. The steam lines literally run down the street, they run across the field and run that way. They're not like they're all over the field. Yeah. So I don't imagine the impact of the steam lines is more than a little bit. We can actually, there are places on campus we know exactly where the steam lines are because we kill the grass, okay? And we know the insulation has failed. But that's not everywhere. I mean, we would have dead grass if we had really bad leaky steam lines. We would have dead grass.
I was just talking about the heat.
I mean heat leaking. Just heat leaking from a steam pipe will kill grass. Yeah. Yeah, so if you see chronic dead places on campus, oh, there's a steam line under there. Yeah.
Well, you got the map of what's on the south side of the new business building, because they had that torn up for quite a while, and they're putting a lot of piping under there.
The new business building like this one?
Yeah, it's a little hard to see. It's hitting on Laurel,
It's not
basically.
Sherwood, it's very long.
No, right along Laurel.
Yeah, that's it, I think. Yeah, but they're showing.
I'm trying to remember what's, Stacy, help me out here. What have we been doing up there? There's a new, oh, you know what it might have been that they did a bunch of work. There's a new, over here behind, oh, it's all covered up with signs. Over here behind the engineering building, near the engineering parking lot, we put in a new switching station. It's not technically a substation because there's no transformers.
So this
in
was
it.
right next to the
High
sidewalk
voltage
on Laurel,
service.
south of the new business building. I live
Wow.
across.
I have no idea. How's that?
They, okay.
But yeah, we brought in a bunch of underground electrical from the city to serve that new switching station because it used to be all the electricity from campus came through a switching station right about.
No, this wasn't electrical. This was piping right there. I just noticed it because I live over there.
CSU Space Command.
CSU, who knows? You know, we run a city of 40,000 people. I always joke, I help run a city of 40,000 people. The average age is 20. So just think about that. That's a little challenging some days. Which honestly, when we come back to this project, you know, it's some of the benefits. CSU has gotten a pretty good cred for sustainability, and we feel like we have to live that. And the students want to see more stuff, more solar on campus, which you guys would love to hear. Just a week ago, I got approval from the last committee on campus to go out for an RFP for more rooftop solar on campus. So I'm excited about that. And megawatts, lots of building. You can't put megawatts on any one building, right? Like all campus. There will be some at Ardec, there will be some at Foothills.
That's
So-
your cooling load right there.
Solar?
Got panels up there, shade.
Well, not hugely, but yeah. And you got to remember, ironically, there's a bunch of buildings over here that have no air conditioning at all. I mean, this campus was built without air conditioning for the most part, and we didn't really start adding air conditioning until the last decade or so, except to a certain type of building.
With your kind of big picture 2030 goals, do you have enough space to install this type of heating system for future buildings? And is
Great question. We have already been going, where can we put another borefield, right? Look at that map. It's pretty cozy, right?
Parking lots.
That's what Ball State did under a lot of parking lots. It's a really expensive reclamation, right? To dig up a parking lot and replace it. Really pricey. You know where my eyes are?
Hilton, right behind the Hilton.
That's exactly it, yes. Another floodway, right? Because anytime you put something in a parking lot, it's the issue, I won't say this, I say this snarky, but it's true. A parking lot is just a future building site, right? I mean, that's just what we do, right? So who needs cars anyway? It's all gonna be buildings at some point. There's a giant field right about here, right? That we can't do anything with because it's a floodway. And we can't do anything structurally. We can't put a building down there. But we certainly could put a lot of borefield down there. And then we could start talking, because a lot of our utility infrastructure is kind of in this corner of campus. And so yeah, that's one we've been talking about. So yeah, that would be fun. We got to get these two. We really wanted to get Moby online, kind of prove it worked, got our feet, you know, kind of jump in the shallow end, sort of wade in. And then they said, oh, we're building Meridian Village. And oh, by the way, we didn't want to put any, they didn't want to give up the space. Think about this. For an entity that survives on rent for income, if they don't have to put in a boiler and chiller, how many more apartments can they, revenue producing apartments, can they add to that space that they didn't have to put equipment in? So, I don't know, however many. Yeah, exactly. So now we've got two coming at us, and I keep telling people, yeah, I'm really excited about this, but heaven forbid, can we get a couple working and let us like play with it a little bit, and then we'll talk about where it's going to go next? So, but not in the oval. We have been told the oval is sacred. No solar, no bore fields, nothing in the oval.
I think you have an athletic field right across the road from that Meridian Village that you could put to good use.
Do you know how expensive that field is? I know, because the contractor had to do it twice. Yeah, they had to tear it up and redo it because it failed warranty. So yeah.
You said the boilers are 1960s, I think, early on. What's the long-term plan for this?
Oh, at the steam plant, great question. That's the other project. I got approval for 3 big projects, and I'm like, my husband did these. Are you ever going to retire? Yeah, probably not. The other thing we just got approved was a district energy master plan to ask exactly that question. We've got these 3 steam boilers. Our system is built on steam, but there's a lot of people, Stanford's kind of the poster child right now, UC Davis is starting it, that they're starting to switch from steam to hot water. And the short story there is, with steam, the heat goes one way. You send the heat out, goes through a heat exchanger, it's a condenser, you get the hot water back and you turn it into steam and you send it back out again. But it's a one-way trip, right? Whereas with hot water, if you have hot water loops around campus, you can move heat between buildings, you can move heating and cooling back and forth. So we're having those conversations as like, we're at kind of a critical point with having to replace some of our boilers over the next 4 or 5 years. So we're kind of exploding our minds going, would we think about doing a Stanford and spend 2.5 years digging up every street on campus to put in new piping? We're not as well endowed as Stanford is, so it's probably not going to happen. UC Davis has a plan. They're going to do it over 15 years. But they do it. It's intriguing. Duke University has done it as well. And the steam to hot water conversion, it's like, how do you do that? Because you can't just like suddenly have new infrastructure. So they do it piece at a time. Like they'll take a corner of campus where they might be remodeling some buildings, and they'll install a little building with a steam to hot water heat exchanger. And then they'll serve those new buildings with hot water. And then you sort of do another little chunk of campus and you have another steam to hot. So all this time you're still making steam. You're still serving everybody with steam sort of indirectly. And then in the end, at some point you say, okay, now all the steam boilers go away and we serve everybody with hot water. So stay tuned. We'll know more once we finish our study.
You have high pressure or low pressure steam?
Our steam is about 45 pounds.
Okay.
I don't know how you characterize that, but yeah. We actually make it, yeah, Navy guys all say that, yeah. We make it in the plant at 150 maybe a little less than that, and we run it through a back pressure turbine and actually generate in the wintertime about 750 kilowatts of electricity. And then we distribute it around campus at about 45 pounds. You guys are grilling me.